Okay, the purpose of this video is to work one more problem for Chem 100 Exam 8 Chapter 16 review. I noticed when I was processing the main video from today's class that I missed a problem. So I want to put that one in this supplement. And first I need to share the same document we were using today. If I can find it. Here it is. There it is. Okay. All right, so the problem I want to work is not difficult, but it expands on the deducing the pH from a concentration of an acid or a base. In this case, it's a base. So problem number 13, which I missed today. Let's work that one. Okay. So, which has the higher hydrogen ion concentration of these two? All right, so we're looking for the hydrogen ion concentration, and we're comparing this one, molar rubidium hydroxide. So rubidium is an alkali metal, which means it only has one hydroxide. This is a +1, that's a -1. Okay, we're going to compare that to 0.2 molar calcium hydroxide. Okay. So we have to assume, for the purposes of this problem, that both of these are completely soluble and that they are both strong and they decompose completely in water. If we don't do that, then I can't work the problem for you because we haven't covered enough information, and we don't have enough information here to work the problem if it's not completely soluble. So we have to assume that both of them are soluble. All right, so we want to see what's the hydrogen ion concentration. Well, first of all, these are bases. So the first thing we're going to do is determine what is the hydroxide concentration. So this one, 0.4 molar rubidium hydroxide, since it decomposes into, well, actually, that's not true. It goes all the way to rubidium and hydroxide. Okay, so that means that this concentration is the same for that one. So this concentration is going to be 0.4 molar. Okay, this one makes calcium and 2 hydroxides. Right? So if this molecule starts off at 0.2 molar, then the hydroxides are going to be twice that concentration, which means this one is also going to be 0.4 molar. Okay? They're exactly the same hydroxide concentration, which means in aqueous solution that the hydrogen ion concentration is also equal. Right? Now, let's look at our options here. What answers do we have? Which has the higher hydrogen ion concentration? Neither one. They're exactly the same. Right? So A can't be the answer. B can't be the answer. The answer doesn't depend on the volumes because we're given concentrations, right? That's an intensive property, which means the volume doesn't matter. Concentration will be the same no matter how much volume you have. So C isn't the right one. Neither is higher. The hydrogen ion concentrations are equal. That's your answer right there. All right. So that's all there is to that. If we were actually going to calculate the hydrogen ion concentration for, say, this one, then it's important that you convert this to actual hydroxide concentration. Then you can work it like any other problem. Once you know the hydroxide, it doesn't matter where they came from. You can introduce those into our equation where Kw equals like that, right? This is equal to 1 times 10 to the minus 14. So we would just plug in this one as 0.40 and then calculate what hydrogen is. Okay. But we did several of these in class today, but we didn't actually work a problem where we had different numbers of hydroxides that were important to the problem. There was one of them that mentioned calcium hydroxide, but the concentration of hydroxide was already given. So it didn't matter where it came from. But in this case, it does matter because we're starting off here and we have to go to this concentration to make the comparison. Okay, so that number 13, that's the only one that I missed today that I wanted to be sure that you were able to review.